So this is the next one. Next topic is polygon. So what is a polygon? See, there are many figures which are lying on your screen. Okay, a simple closed curve. Okay, simple closed curve means they should not means starting point and ending point should be same and they should not intersect. So that is a simple closed curve. Okay, so simple closed curve we understood. Okay, simple closed curve which is made entirely with the line segment should have the lines. Should have the lines. Okay, so if you see the diagram, everything is made up of line segments. Everything is made up of a line segment. There should not be a curve. Should not be a curve. Okay, it should be closed. Okay, it should not intersect, as well as they should be made up of line segments. So these are the three conditions which you should consider to tell that it's a polygon. Okay. Okay. So the three conditions, okay, are there. Okay. So if you'll see, okay, there are many polygons. Okay. If you'll see the diagram which are lying on your screen, there are many polygons which are available. Okay. If you'll see, all are made up of line segments and they are closed and they are not intersecting. Okay, and they are not intersecting. Okay, these all are polygons. They may depending upon the sides and angles, they are different. Okay, so you understood. Okay, the next one. So the next topic is classification of polygons. The polygons are further classified into two types. Okay, so there are two types. Okay, they are convex and the concave one. Okay, okay, so before that we have already understood what are polygons. Okay, let us differentiate between what a polygon is there and which one is not a polygon. Okay, let us see. So these are the four figures. Now we have to identify which one is a polygon and which is not a polygon. First we have to understand that one. After that we will go to the types. Okay, so what are the conditions for the polygon? What are the conditions for the polygon? First one, closed curve. Okay, second one, it should be what? It should not intersect. Third one, they should be made of line segment. Now first one we'll see. First one is, it's a closed one. Yes, it's a closed one because opening and the starting and same, opening and ending, opening and the same, opening and the same, opening is ending not same. So it's not closed. Okay, so not closed. Okay, so everything are closed. Okay, one by one. Next point is, they should be what? They should not intersect. Not intersecting, not intersecting, not intersecting, not intersecting. Great. Okay, they're not intersecting. Great. Next one, they should be made of a line segment. They should be made of the line segment. So line segment, yes, all are line segment. Okay, line segment, all are line segment. No, this is not a made of line. This is line, but this is a curve. Okay, not a line segment, not a line. Okay, so he has not satisfied the first condition only. She is not a polygon. So not a. It has not satisfied the third condition. So not a polygon. As they both have satisfied the condition, they are polygon. They are polygon. Simple. Okay. So three conditions, three options, just like in KBC. We get three options, na? A, B, and C. Just like that only. Okay. Let's go for the next one. So if you'll see the picture again it's saying that a poly has another word for shapes. Not just the shape through. Okay. Means if polygon is there, it's not a polygon. Okay, why polygon? Because the conditions, you know the condition, and the conditions, you know why it's not a condition. Just apply the condition and get your answer. Okay, apply the condition and get your answers. Okay, so the two things are there. Okay, visible to you? Yes sir, it's visible, clearly visible to us. The next one is convex polygon. So if you'll see, there are many diagrams which are available on your screen. So these all are convex polygon. Okay, these all are convex polygon. Okay. So again some more diagrams are also visible to you. This also convex polygon. Okay. Now sir, how to identify they are convex polygon or not? How to identify, sir? Now if you will see the diagram which is available to you, okay, and the condition they are saying that all interior angles measure all interior angles should be less than 180. First condition. Second condition, all diagonal lines inside the closed figure. All are inside the closed figure. What do you mean by this one? Let me show you. Now see the diagram. Okay. First condition, all interior angles. What do you mean by interior angles? The angles which are lying inside. We know this one. So interior angle, interior. Okay. So tell me, all these interior angle are less than 180 or more than 180. Sir, what do you mean by that one? What do you mean by that 180 or 180 less than 180, more than 180? So there is a figure which is showing you and telling you there is the angle which is less than 90 degree. Okay. See the diagram, the angle is less than 180. Okay, the angle is less than 180. Okay, so this is the angle less than 180. Okay, so there is a diagram, the angle which is greater than 180 degree. See, so there are two things which we saw, one is less than 180, one is greater than 180. Okay, so according to that, okay, we need to use this one. According to that, we need to tell me, okay, whether these angles are less than 180 or more than 180. So simply they're trying to say that, so if you see this one, so diagram I have drawn for you, means this is a red line. Over the below this is there, below this one, not below this one. This line, this line. If it is the line is above this one, so it is less than 180. So this is the line. So less than 180. Okay, above this one. So if it is below this one, more than 180. Okay, if a line comes like this, so it's a more than 180. If it is come like this, just like I will say like this. So it's a less than 180. If in the case if I am saying that like this I am doing na, so just make a border line, the red one. So it's above this one, so less than 180. Now if the same thing I do like this, if I will say like this, and I will consider this one, if we consider this one like this, so more than 180. Okay, okay. So many students are know what is less than 180, more than 180. Then also small thing is there like this, so less than 180. Okay, so by using this one only we will come to know whether the angle, the polygon given us is a convex or concave. So what do you mean concave? I will tell you. First is convex, and one more thing they are saying. What they are saying? All the diagonals which are being made, okay. So all the diagonals. Now sir, what do you mean by diagonal? I will tell you that one also. But to understand this one, you need to understand the diagonal also. For that, you just understand now it's a diagonal is there. Okay, simply. Okay, so how to tell you? First, I have to explain what is diagonal, right? Okay, after that, I will tell you what the word I am telling you diagonal. Okay, they are saying that all the diagonals are made from the inside only. Now, simply you understand that. Huh? Okay, like this, join them like this, inside point. Okay, inside point, again inside point. So all points which I am joining are inside or from the outside, sir, all are inside. So this is the second condition. First condition is less than 180. Second condition, all the diagonals should be from inside. They are all the inside. Okay, these are the two conditions to tell us that the polygon that you have given to us is a convex polygon. Okay, understood? Okay, then let's go for the next one. Now some of the students are asking to me, sir, how I will come to know it's less than 180, 180 or more than 180? Okay, now see that, for example, this is a base and this is a line. So less than 180 or more than 180, this one? Sir, less only. Okay, again this is a line like this. So less than 180, more than, sir, less than only, because this is a margin line. Now this one, sir? Okay, so this is a line like this. So it is again less than 180. Red line like this. Okay, again here dot. Again it's a less than, yes sir, less than. So like this, again it's a less than 180. Okay, so we can do anywhere. Okay, sir, all are less than 180. Okay sir, so thank you sir for explaining us, okay, clearly. Okay, how to see whether it's less than 180 or more than 180. Okay, so you understood. Okay, so what I'm trying to say, so this is a line. Okay, it's above this one, so less than 180. A line above this one, not below. So line, okay, above this one. Okay, understood. So all this one which are above this one, above the line, they are less than 180. So we have satisfied the condition of a being a convex polygon. Okay, so this is the next one, that is concave. So convex you have understood. First we will understand concave, then we will see some of the sums over how to identify whether it's a diagram is a concave one or the convex one. Okay, so see, some of the pictures are lying on your screen for the convex. Okay, so for the convex, what is the thing that we need to identify? Okay, the angles, if any one of the angle of the given angle is greater than 180, so it's a convex. And the diagonals, if any one of the diagonals are lying outside. Okay, let us see how it works. Okay, so if you'll see, okay, so let me first, what is the thing that we have to identify? We have to see the angles. If any angle is greater than 180 or not, first we have to see that one. Okay, so if you will see this one, this is less than 180. Okay, smaller one. This is also less than 180. See, okay, and this one is also less than 180. But when you come for this one, see, this is, if this is bigger than 180, if you will see this one is bigger than 180. Okay, so we will say that as this is greater than 180 degree, this one, any one of the angle. Any one angle should be greater than 180, that is a convex one. And one more point is what? The diagonal are lying outside. If you will see the diagonals, the 1 point, 1 point. If I add these two, this is diagonal. So diagonal is not lying inside, this is lying outside. Okay, two condition. Any one angle should be greater than 180. Okay, and one more condition is the diagonal should be outside. Both the conditions should be satisfied. Then only it is a convex. concave, okay, convex, opposite to this one. Diagonals will be inside and all the angles should be less than 180 degree. Clear? Okay, let's go for the next one. So there you go. This is the next question. Okay, so they are saying this is also concave. So concave means there should any angle should be greater than 180 degree. Let us see the diagrams. This is 90. This is 90. We know this one. This one. This is less than 180. Smaller one. Okay, less than 180, 90, around 90, around small, less than 90. But when you come for this one, it's greater than 90. So 180 because of this complete okay, of this complete is a complete angle. Of this complete, only small portion is left here. So the big portion is this one. Of this complete, of in this point, for example, I will make it more clear for you. If this is a point, like this is the point, okay, and over this point, complete around, it's a 360 degree. Completely, it's a 360 degree over the point. Over the point is a complete 360. And if I make it half, so this above is 180, this below is 180. Now 180 plus 180 360. Now if I'm having more than, for this is the point, okay, and I have this value and this value, so the green one, this is the point, this is the red point, the point. So red one is there, the value angle, and the green is also an angle. So which one is bigger? You tell me. So green is bigger. Green is bigger as compared to the red one. They are not equal also. So we can say that this angle is greater than 180. We can say that this angle is greater than 180 degree. So first condition is satisfied. Now if you see, sir, we can apply remaining angles also. Apply. See this one. Okay. See this one, green is there, and the red one. Which one is bigger? So red one. So the inside is smaller. Again inside is smaller. Again inside is smaller. Again inside is smaller. Again, but here you will see inside is bigger. So it's greater than 180 degree. We can say that like that also. Okay, very useful for us. Means greater than 180 degree. So one condition is satisfied. Second condition, the diagonals are outside. So add the points. So diagonal is outside, the green one. So two conditions are satisfied. So it's a concave polygon. Clear?